Hi girls! So we are going to continue looking at triangles, and in fact we're going to be looking at special types of right triangles today. And we're going to look at two specific theorems that deal with ones that have a certain type of angle inside, and then look at the relationship that they have with the legs and the hypotenuse. So let's just go ahead and jump right in and take a look at our first example, which is the 45, 90 degree triangle theorem. So what this theorem says is that in a 45, 90 degree triangle, which is what we have over here on the right, the hypotenuse, which is this long side here, is the square root of 2 times as long as each of the legs. So let's take a look at two examples that are applications of this theorem. So we are asked to find the value of x, and we're going to write our answer in simplest form. So we can look at this triangle right now and identify that it is in fact a 45, and a 90 degree triangle. And so if we know that that is true, we know that this is our hypotenuse, right, this x. And if we go back to our definition up here of this theorem, it says that the hypotenuse is equal to the leg times square root of 2. So this is the hypotenuse, so we're going to say the hypotenuse, which is x, is equal to the leg, which we know our leg is 8, times the square root of 2. And we can just simplify that by getting rid of that multiplication symbol. So it just becomes 8 root 2. All right, so now let's take a look at part B. And if you want to pause the video and try it on your own and check your work right after, that would be a good option to see if you're getting this. So let's go back to our triangle here. We know that this is a 90 degree angle. Because this side x and this side x are the same, we know that this is an isosceles triangle, so we know that these two angles have to be the same, and we know that if we take 90 and divide it by 2, that gives us 45. So, oops, I don't know why it's not rating on there. So we know that that angle is 45 angle, and that's a 45 degree angle. So now we can use that theorem. So let's go back to the definition. The hypotenuse is equal to the leg times the square root of 2. So our hypotenuse is right here. So we can say the hypotenuse, which is 5 root 2, is equal to the leg, so our leg is x, times square root of 2. So we need to solve for x, right? So to solve for x, we need to undo this operation. So since this is multiplication, we're going to divide both sides by the square root of 2. So those would become 1, and those would become 1. So we get an answer of x is equal to 5. And that is the side of your leg. All right, now let's jump down to the second type of special triangle that we're going to study today, which is our 30, 60, 90 degree triangle theorem. So they're saying in a 30, 60, 90 degree triangle, the hypotenuse is 2 times, right? So this is the hypotenuse. It is 2 times as long as the shorter leg. And the longer leg is the square root of 3 times as long as the shorter leg. And we can use this shortcut down here to help us. So we have another set of examples to use when looking at this type of triangle. So in example 2, we're asked to find the values of the variable, write our answers in simplest form. So we have a 30, 60, 90 degree triangle, and we are asked to find the length of the longer leg. So I'm going to go up here and look, oh, the longer leg is equal to the shorter leg times the square root of 3. So the longer leg, x, is equal to the shorter leg, which is root 3, times square root of 3. So then we just simplify that. So square root of 3 times the square root of 3 is the square root of 9, and we know that the square root of 9 is equal to positive 3. So x equals 3. All right, let's take a look at example B. And again, you can pause your video if you want to try this on your own and then check your work. So we're asked to find the length h right here. So if we look at this triangle, we notice that the sides is 4, 4, and 4. So if you recall, this is an equilateral triangle, which means that if all the sides are the same, all the angles are the same, right? And if we have 3 angles that are the same, if we take 180 degrees and divide that by 3, we get each of the angles are equal to 60 degrees. So that means that that's 60, and that's 60, and that's 60. But we're asked to find just this distance here. So if I want to find the angle, and I'm just going to color this where the green angle is, just this part here, we know that this red line bisects this 60-degree angle. So the green angle is actually going to be 30 degrees. So now I can use my 30, 60, 90 triangle theorem to help us solve this. So I'm going to actually just take this triangle here and outline it in blue so that we just look at this blue triangle here. Okay, so we're asked to find h, which happens to be the longer leg, right? So again, the longer leg, h, is equal to the shorter leg times root 3. Well, my shorter leg is 2, and I'm going to multiply that by root 3. So I can just simplify that by writing h is equal to 2 root 3. And that's your final answer. All right, so now what we're going to do is take a look at 2 different applications to this and determining which theorem we're going to use. So if I look at example 3, I have a road sign that's shaped like an equilateral triangle. We're going to estimate the area of the sign by finding the area of the equilateral triangle. So if we recall, the area of a triangle is area equals base times height divided by 2. So in order to find the area, we're going to need to find the base and the height. Well, right away we can figure out that the base is 36, but we do not know what the height is. So we need to find the height first. When I drew in this blue line that represents the height, I made a right triangle. And if you remember from our last example, if this is an equilateral triangle, all of the angles are 60 degrees. And if I want to just highlight, I'm going to actually just draw it in green, just this triangle here, so I can find that value for h. I can also identify that this small angle here is 30 degrees. So now I can use my theorem, my 30, 60, 90 degree angle theorem, to help solve our problem. Well, if this is 36 inches, I know that this is also 36 inches. But I only need this distance here. So if I'm finding half of that, 36 divided by 2 is going to give me 18. So that's 18, right? So I'm asked to find the longer side, right? And if I go back and I look at my definition, I'm going to scroll back up, my longer leg is equal to the shorter leg times root 3. So my longer leg h is equal to my shorter side, which is 18, times root 3. So this can be simplified to h equals 18 root 3. So now I have my h and I have my b. So now I can plug this all back in and get the area. So I'm going to start with area equals the base. So remember, our base of our triangle was 36 inches times the height of my triangle, which is 18 times root 3. And I'm going to divide that all by 2. So you can just use your calculator to get a decimal approximation. So when you type all of this in, you're going to get 36 times 18 times root 3, and then press enter and then divide everything by 2. And you should get an answer of 561.18 inches squared. And that gives you your area of this equilateral triangle. Okay, last example that we're going to look at is example 4. So we have a tipping platform that is a ramp used to unload trucks. So if you have your truck and they raise the height of the ramp so that they can unload the trucks. We want to know how high is the end of the 80-foot ramp when tipping at a 30-degree angle. So we've got this right triangle here. We know that this is 30 degrees. And then by default, this has to be 60 because we've got 90 here. So this is 60 degrees. And I know that my ramp itself is 80 feet. So I'm asked to find this distance here, or the h, the height. So we can use our 30, 60, 90 degree theorem again. So if we recall that if I'm trying to find the shorter side, if I scroll back up to my definition here, I know the hypotenuse is equal to the shorter leg times 2. So if I go back, the hypotenuse, which is this long side, 80, is equal to 2 times the height. So this is pretty easy to solve. We're just going to divide both sides by 2. And I get h equals 40 feet. And there you have it. All right, you have a couple of practice problems to complete in your textbook. And if you have any questions on this, please make sure that you come into one of the Google Meets and so I can answer any questions. But I hope you found this helpful. All right, we'll talk soon. Bye.